So now that we've looked at some of our ways of factoring, we've looked at GCF factoring, factoring by grouping, and then factoring trinomials where a equals 1. For this video, we're going to go and learn two more ways of factoring. One is when a is not 1, so we have a different type of trinomial, and as well as we're going to look at a pattern we call difference of squares. So to start with, we have two options whenever we factor when a is not 1. The first is bottoms up. If you prefer FOIL, when you multiply, this one is kind of like an opposite FOIL. Okay, so if you prefer FOIL, this might be the route you want to take. You may prefer the box method, but then like this method whenever you factor. It does not matter. Just like with multiplying, you just need to be good at one of them. Okay, this is our first option. The second one we'll look at in a minute is reverse box. Both of them will get you to the correct answer as long as you do them correctly. So as long as you're good at one of them, that's all you need. Okay, so if you like FOIL, you might like this option better. We call it bottoms up. This is what happens when a is not 1. And when a is talking about in standard form, we have ax squared plus bx plus c. So anytime this a is anything except for 1, we can use bottoms up. First thing we do is multiply a and c. This isn't a bad thing to go ahead and jot down somewhere so that you can refer back to it in class and then as we continue on in the unit. So we multiply a and c, whatever your a and c's are. It's like we're temporarily moving a to make it part of c. Because then we're going to rewrite the equation as x squared, so a is 1 now, plus whatever your b is, bx, plus whatever a times c was. Then we're going to factor like normal. Once we take a and move it to be part of c, this is just like what we factored in class the other day. A equals 1, so we want to multiply to my new c and add to b. Then you have to divide by a. Right? We have to take that a back out, and then you're going to rewrite your solutions and apply bottoms up. And then you'll see what we're talking about in just a second. So for our first example, we're going to do bottoms up. So right now I have an a of 2, b of 13, and c of 6. I don't have a GCF to take out because of this 13. That messes it up for us because 2 doesn't go into 13. All right, so I'm going to have to use bottoms up. So step 1 is to multiply a and c. Alright, so 2 times 6 is 12. That's step 1. Step 2, I'm just going to rewrite it and move that 2 to make it part of 6. So now I have x squared plus 13x plus 12. Alright, I temporarily moved a and made it part of c. Now this I can factor. I want to find numbers that are going to multiply to a 12 and add to 13. Alright, so my factors are 12. We've got 1 and 12, 2 and 6, 3 and 4. Alright, 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7, so my winners are 1 and 12. So I'm going to make my parentheses and have x plus 1 times x plus 12. Okay, if I stopped here and multiplied this back out, I would get to the second line here, not back to my original equation. So the next step is very, very important. I moved a to make it part of c. Now I have to take it back out. So I multiplied to move it there, so I'm going to divide to take it back out. So I'm going to take both of those factors I just found and divide by my original a, which was 2. I cannot simplify 1 over 2, so I'm just going to rewrite that for now. I can simplify 12 over 2, and that's going to simplify to 6. Now, factored form will never have fractions in it. So in order to avoid having the fraction, we're going to apply bottoms up. So I'm going to take whatever's on the bottom and move it up in front of my x. So then in this case, it's going to become 2x plus 1 and x plus 6. This 2x and x is what's going to multiply to get me to that 2x squared in the very beginning. Reverse box. So this is also a method we use whenever a is not 1. And the first step, again, just like bottoms up, is you multiply a and c. Then you're going to create your box for 2 binomials. So it's going to be a 2 by 2 box. Then we put the first and the last terms in our corners, because that's whenever we multiply, those are the 2 that are the easiest. Then we have to find the other 2 boxes by finding factors that multiply to whatever a times c was and add to the same b. Then you take the GCF from each column and each row. So again, it'll make more sense when we do it. So for this example, 2x squared minus 19x plus 24. First thing I'm going to do, multiply a and c. So 2 times 24 is 48. We're going to kind of come back to that later on. Then I'm going to make my box. I know it's going to be a 2 by 2 box. And I know my first term is always this top left corner, so that's where I'm going to put my 2x squared. And then my last term is always the bottom right corner, so that's where I'm going to put my 24. So now I'm just going to figure out these two boxes, and to do that I'm going to figure out what's going to multiply to a positive 48, but add to a negative 19. So remember, if I'm multiplying to a positive but adding to a negative, I'm going to have two negative numbers. And if I think about some of my factors, you've got 1 and 48, 2 and 24, 3 and 16, and then I notice 3 and 16 can give me a 19 if they're both negative. So I'm going to put in a negative 3 and a negative 19. Now think back to when you multiply, negative 16. Think back to when you multiply using the box method. There aren't just numbers in these boxes. This is also where our like terms go, which have that x with them. So I'm going to put the x in here. Now this is what it looks like whenever I multiply a binomial times a binomial. So to get back to my binomials, I'm going to work from this bottom right corner away, and I'm going to find the GCF. Now remember, GCFs, you always keep the sign that's on the outside, or the first sign. So I'm going to keep whatever sign is on the outside 3 boxes. So my GCF of negative 16x and 24 was going to be a negative 8. Alright, they don't both have x's, so I can't take out a variable. 2x squared and negative 3x. 2 and 3 don't have anything in common, so it's just an x. 2x squared and negative 16x would be a 2x. And negative 3x and 24 would be a 3. I'm going to keep it negative because that's what's on the outside, so I have a negative 3. These are now my binomials, so I'm just going to write them in my parentheses. So one of them is x minus 8, and one of them is 2x minus 3. Again, the 2x times x is going to give me my 2x squared to begin with. And then if I FOILed it all out, I would get back to 2x squared minus 19x plus 24. So that's the reverse box method. Remember, you don't have to be able to do both. Just pick one that you're most comfortable with and become a pro at it. Perfect squares. Alright, that was our first option, or first way of factoring for this video, and that's an a is not 1. Then we're going to look at difference of squares. Right, so what is a perfect square? It's a number formed by squaring a number or a polynomial. So examples, 4, right? 2 squared is 4. 10 squared is 100. Right, 16 squared is 256. So all of these are perfect squares. And x squared is also a perfect square. X times x. If I did x cubed times x cubed, right, I add my exponents, so x to the 6th is a perfect square. X to the 5th times x to the 5th would give me x to the 10th. Right, so if you have an even exponent, it's going to be a perfect square. And to find the square root, you just cut it in half. So x to the 18th, square root would be x to the 9th. Okay, so we got our perfect square coefficients and we got our perfect square polynomials. Alright, whenever we are factoring, look for these perfect squares. Okay, so for example, I have x squared minus 9. Right, if I were to factor this like normal, okay, and add in, right now I don't have a b term, so I'm just going to add in a 0. Right, a 0x and then minus 9. So if I want to factor this using my plain Jane trinomial, multiply to c, add to b. Well, some factors of 9 or negative 9 are 1 and negative 9, negative 1, positive 9, and then we've got 3 and negative 3. Well, if I add 3 and negative 3, that's going to give me my 0. So if I factor this, I get x plus 3 times x minus 3. Well, this is going to happen every single time when we have this difference of squares pattern, right? Because if I FOIL it back out, right, x times x is going to give me my x squared, and my last terms, 3 times negative 3, is going to give me the minus 9, but the middle ones end up canceling, because x times negative 3 is negative 3x, and 3 times x is positive 3x. So those end up canceling, and I get x squared minus 9. If you can identify this pattern in the beginning, you can skip straight to this pattern. So whenever we do difference of squares, you have to have difference, so it has to be subtraction, and it's got to be two perfect squares. Once you recognize the pattern, you find the square root of the first term, find the square root of the second term, and then you're just going to plug it into a plus parentheses and a minus parentheses. So for example, 4y to the fourth and 25z squared. 4 is a perfect square, 25 is a perfect square, y to the fourth is even exponent, and z squared, even exponent. So this is difference of squares. 4y to the fourth, right, the square root would be a 2y squared, and 25z to the second would be 5z. Once you have your square roots, we're going to have the first square root plus the second square root, and then the first square root minus the second square root. And that's it. Find your square roots, plug it into your pattern. It's as simple as that. For this example, I have 3x squared and minus 48. So I've definitely got my subtraction, but 3 and 48 are not perfect squares. However, there is a GCF between these two terms. You always look for your GCF first. So if I take out a 3, that's going to leave me with x squared minus 16. Now I have difference of squares. This 3 is still going to be part of my answer. It's still a factor of 3x squared minus 48. It just doesn't go into my pattern. The square root of x squared is x. The square root of 16 is 4. So this part, x squared minus 16, becomes x plus 4 times x minus 4. And then that 3 goes out in front. And that's all you do once you realize this difference of squares.